axis intersect intersect JK line. So JK line, right, is basically this line over here. I'm sketching in red. Okay, JK line. So on JK line, one thing is constant is that Z is equal to positive 0.01 divided by 2 meters. Right? So on the JK line, the Z, the thing that's constant is the what? Is the Z which is positive. So this is equal to 5 times 10 to the power minus 3 meters. Okay. Now you ask me, Eugene, why is that important? Okay. So now we use the equation, right? Stress X is equal to 1.359 times 10 to the power 6 plus by N, okay, my over Iyy multiplied by Z. Now this Z now is positive. Okay. And then plus or minus by N mz over Izz multiplied by Y. It is this Y that we want to identify. This is the Y will tell us where the stress zero will intersect the JK line. Okay. So we know on stress X has to be equal to 0, right? So this is equal to 1.359 times 10 to the power 6 plus by everything we focus on is on the steel. Moment about Y, we know moment about Y is what? Moment about Y 375. So now you have to include minus 375. Divide by Iyy. So Iyy is what? 2.859. Multiply by 5 times 10 to the power 3. Then minus by 200 over minus by 200 over 104. And then now the N, the MZ, you also must include the minus. Okay, so minus 17, come on, UJ, minus 17.936 times 10 to the power 3. Y is what we want to find out, and then divide by the 65.694. Times 10 to the power minus 6, right? So once I write this out, I will copy. So this will be equal to 0, 1.359 times 10 to the power 6 plus, no, it will be minus because it's a minus sign down there. Minus by 200 over 104 10 by 375 10 by power 3 divided by 2.859. Oh, that's minus 3 down here. Sorry. It's a 3 millimeter. So 375 times by 5 power minus 3 divided by 2.859 power minus 6 times by 200 divided by 104. So it's minus by, so it's again minus by 1.261 times 10 to the power 6. And then this one will be plus. Okay, so will be plus will be 200. 536 power 3 by 104 by 65.694 power minus 6. 525.045 times 10 to the power 6 y. Okay. So finally, y will be equal to 1.359 minus 1.261 positive. So minus 0.098. That's by 10 to the power 6. Divide by 525.045 times 10 to the power 6. Okay. So 0.098 divided by 525.045 is equal to 0.1867 times 10 to the power minus 3 meters, or 186.7 times 186.7 millimeters minus. Now, if you it's good news. If you got plus sign, it's bad news, and I'll tell you why. So if you look at this figure again, right? So this is just a sketch. Okay, I'm going to sketch this out. All right. So we know that this is our y-axis. The vertical axis is our y. And going up, y is positive, and coming down, y is what? Negative. Right? So we know that it is down here. Negative means it's down here. Okay. And why I say good news? Because it is a linear function. What do I mean by a linear function? If you look at here, this is 62.059, this is 92.729, right? So if I were to sketch this, right? If I were to sketch this, right? And if I would sketch in proportion, right? This is point I, and this is point J, and point I, this is 62, and 92 will be longer, right? It will tend to intersect. So if this is our what? This is our centroid, right? It tends to be at the lower end. That's why I say minus is good. Okay, if it's plus, I'm not saying it's wrong. You have to check. Okay. So we have found where the line will intercept. So this is I, J, K, and L. So next we have to find the intersection. Okay, of the line of the neutral axis along the line along I and L, right? So everything is the same. The only thing difference is now, right? At I and L, right? Z now is equal to minus 0. Equal to minus 5 times 10 to the power minus 3 meters now, right? Because this line over here is 5 times 10 to the power minus 3. So that's the only thing that changed. So if we were to write the whole equation, the rest, everything the same. Okay, so if we are going to transfer this into here, or not this one, this whole thing into here, the only thing that is different now, you use the same equation. Oh my gosh, you use the same equation, right? The only thing now is you put a minus over here. right? So now you have a minus over here, right? Because it's our Z. So this will be 0, and this will be equal to 1.359 times 10 to the power 6 plus 1.261 times 10 to the power 6. And then the last one is still the same. Okay. And then finally, y will be equal to 1.359 plus 1.261 minus 2.62 times 10 to the power 6 divided by 525.045 times 10 to the power 6. So 2.626 divided by 525.045 is equal to 5. Okay. Is equal to, wait, 2.62 divided by 5 to 5.0. Okay, it's 5 times 10 to the power 3 meter, or you can still hear me, right? Or 5 millimeters. Can you hear me? Can someone type yes? Because my headphone just went out.
Yes.
Okay, good. Okay. So this is the answer. Okay, for the wait, is it minus? Okay, so minus. Okay, so minus 5 millimeters from the neutral axis. Okay, so if we were to sketch this out, okay, I'm about done. Okay, I know this is a long problem. So if this is the structure, right? So if this is our y or our neutral axis, right? This is our neutral axis. Again, this is just a sketch. So at one point is 186.7 millimeters. Okay, so this is our y, right? So at one point, so we know from here to here. Again, I just say this is just a sketch. We know that this distance over here is, I can't, is it 123.207? I can't remember now. Let me check. I think it is 123.207. Yep. So the distance from here to here is 123.207, right? So at one end, it is 186.7. So this is 186.7. Okay. So this is 186.7. Okay. And then the other one is 5 millimeters. So 0.092 divided by 525.045. 0.18. 0.18. So 2.62 divided by 525.04 is equal to 5. Yep. So the other one is 5 millimeters from the top. So 5 millimeters, this is your 5 millimeters. So the orientation of the neutral axis, okay, this is again just a sketch. I will draw the green line, right? Hey, what am I doing? Silly stuff. So if I were to sketch, so you will look like this. Okay. So this is the orientation of the neutral axis. Okay. If that's the case, I will still be, again, this is just a sketch. Okay. That's all for my class for today. I'll see you on now. In your term test, you will test up to here. Okay, so you have to know the example. I posted the homework and I've also posted the solution. Okay, please do them. Okay, if that's the case, thank you, and I see you guys Tuesday next week.